Hey, this is Van. Before we start the videos, I just wanted to offer you something for free. It's a PDF Wireshark display filter cheat sheet. It has some good filters in it that I know you will find useful. No signups or anything like that, just free. So go to www.LanWanNinja and click here. Hey, while you're clicking on stuff, why don't you click on subscribe to my channel and get more great videos and resources like this. Now, on to the video. Hey, this is Van. What I've got for you today is a video that I'm really excited about. What we're going to do today is really analyze and work through the packet capture. So let me set up the scenario here. We've got an application that's not working properly that uses port 80 HTTP, and the apps department doesn't know why it's not working, and they need some help with it. So we've got a packet capture that we've taken here. Our job is to take a look at it and see what the problem is. Well, the first thing I would normally say would be, okay, let's filter by the source and the destination IP. But in this case, we don't know what the destination IP is. All we have is a URL to go by. So the URL is www.LanWanNinja. In this case, it's my website that we're using here. So let's go ahead and get started. And I will tell you, somewhere near the middle of the end of the video, we're going to have a really great filter that's going to help us here and can help us in a lot of other situations. So stay tuned and let's get started. So the first thing we're going to do here, since all we know is the URL, we're going to type in just DNS. So we just filtered by DNS. We put DNS in the filter box, and there's still a lot of stuff there. If you look down at the bottom of the screen, it says there's still 84 packets. Let's make it a little bit easier. So we've clicked on one of these DNS packets. Over here on the left-hand side of the screen, we're actually going to find that DNS query. In this case, it's accounts.google.com. I'm going to right-click on that and go to Prepare as Filter. So we're going to do Prepare as Filter, selected, and then we're going to go up to the filter box here and actually edit that. What we're going to do is we're going to change that to www.LanWan.Ninja and then hit enter. We've just taken those 84 DNS packets and reduced it to just 8. So now with just 8 DNS packets, it's pretty easy to see what our destination IP address is. So we can tell in this case, it's 192.168.1.166. So let's go back up to our filter box here and type in what I already know my source address is, which is ip.addr = 192.168.1.158. Then we're going to put and ip.addr = 192.168.1.166 and hit enter. So now we've distilled that traffic down to only traffic between those two devices. The first thing I see here is another problem. There's a bunch of DNS packets. Since we have our destination IP already, we don't need to see all these DNS queries. So now let's type and not the exclamation point DNS. So we've taken out all the DNS packets. Now what do we see? Well, remember I said this is port 80 that the application department have said that their app uses. What we're seeing here is the behavior of our web browser. If you notice here, in this very first packet, the destination port is 443. Well, we didn't put in HTTPS and we didn't tell it to use port 443, but the browser is going to automatically try to use 443 because it wants to use an encrypted port and it wants to encrypt the traffic. In our case, though, the web server is not responding on 443. Another thing to notice here is our source port is 58528 and our destination port is 443. That source port of 58528, you may wonder where that comes from. Well, that's called an ephemeral port. Think of it as a dynamic port that the operating system uses as a source port to get to our destination port of 443. There's a whole lot of different ranges that different operating systems can use for the ephemeral port. Let's look at a couple examples here real quick. Windows 10 can use a number of different ranges. In my case here, it's using port 1024 as a start port, and the number of ports is 64,511. The command that I use to find that out is here on the screen. I've also included here another way to show the dynamic ports. If you're using Linux, it should work with most versions of Linux. But back to this first packet, we see our computer sending a send packet, and instead of just sending an ACK packet back, the server is sending back an ACK and reset. So it's ACKing the connection, but it's also closing it with the reset. One more thing to notice here, you see that we have source port 58528 and destination port 443. You notice on the return packet, port 443 becomes the source port from the server, and our 58528 becomes the destination port. And we can see this process repeat itself several times. The client comes in on port 443 looking for an encrypted connection, and the server says, no. So what's our next step now? Let's get rid of these port 443 packets. What I'm going to type is and not tcp.port equals 443. So now we're really getting down to what we want to see. We've got it filtered down now to 184 packets. And this is still not the filter that I think is a really, really great filter. We're not there yet, but we're getting there. So if we notice here, let's look for our three-way handshake. We see the SYN packet coming from us on this port 58534. Next, we see a SYN-ACK packet coming back from the server, again on that port 58534. And then we see an ACK packet coming from us. I'm going to take this first packet and I'm going to use a comment. I'm going to add new comment and I'm going to say three-way handshake and hit OK. Well, that's great that it displays it here in our packet comments section of the packet details, but we need to see it on the screen, right? So let's do that. I'm going to click on three-way handshake here, going to right click, and I'm going to say apply as column. So now we can see our comment as a column in our packet list. I'm also going to use another really good feature here. I'm going to right click on this packet and I'm going to mark it. What we're really interested in here is seeing the HTTP gets and posts and their replies. So let's just think of all the ACKs and SYN-ACKs and everything like that for now as TCP housekeeping. Here's the GET request where our client is requesting what's at the root of the web server. We'll go all the way over to the left here and see the arrow pointing to the right is our request. And if we look down here just a little bit, the arrow pointing back to the left is the reply. So we see the reply 302 found. It looks like the web server replied and no issues. Next, we see get login.php. So it looks like to me that this is where the server is requesting us to log in. That seems important. So again, I'm going to add a comment. The comment I'm adding is just login request. And you can see my comment is displayed there. Scroll down here a little bit more and we see a post. So in this case, this post is the application logging in. So let's scroll down into the packet details and we can see here where the application is logging in. We see username with the value of admin and password with the value of password. Yikes! That's not a very secure password. Let's also think about this. We're just seeing network traffic, and we can see that password. Sending Cleartext passwords over the network is never a good idea. You don't want this guy on your network looking at all your passwords, do you? I'm going to comment the post as app_cred sent Cleartext. So if we keep following through here, we see a get index.php and look over and see the reply, HTTP 200, okay. We see a get vulnerabilities brute, HTTP 200, okay. So everything's looking good up to this point. We're seeing requests and we're seeing replies. If we look down at the bottom of the screen again, we've still got 184 packets to go through. And a lot of those packets are this TCP housekeeping that we're calling it for now, where we're seeing the ACK packets, SYN packets, etc. And that's not to say that the problem can't be in those packets, because it can, just not this time. Can we filter it down some more is the real question. And the answer is, yes, we can. And this is kind of that really great filter that I was telling you about. Because what I'd really like to see here is I would like to see just the HTTP requests and replies only. So to get the HTTP requests, I'm going to add and http.request. That's close to what I want to see, but that doesn't tell me anything about the replies. So let's also add in here the HTTP replies. The way we're going to do that is right after the and in our filter, we're going to put an open parentheses, http.request, then we're going to put or http.request underscore in and close parentheses and hit enter. This is the filter that I was talking about that's going to give us all the HTTP requests and their replies. Here's the reason why it works. If we go here to a request, we can see request method get. If we're going to act like we're adding a filter and go to apply as filter, you can see that says HTTP request method equals get. We are just deleting the end of that and leaving HTTP request. That's the first part of the filter. If we go to a reply here, which this next one is the reply, scroll down a little bit here, we see this line right here that says request in frame. If we right click on that and act like we were adding a filter, we can see apply as filter http.request underscore in. We're just taking off the last part of it, and we're saying that that packet is an HTTP reply to a request in this capture. So now that we've got this filtered down to just 46 packets, let's step through and look at a couple more things and try to find out where that application problem really is. We see a get index.php and the reply to it says okay, that's good. An HTTP 200 normally means there's not an error there. So we see a get vulnerabilities brute, HTTP okay. We see get vulnerabilities exec, HTTP 200 okay. We've got get PHP info okay, vulnerabilities okay. And I'm just going to kind of scroll down a little bit here because if we're seeing an HTTP 200 coming back, it's probably fine. Now there still could be some kind of error in it, but that's not what we're looking for here. It's not sending bad data, it's just broken. So if we keep scrolling down here, get and then 200 okay, get 200 okay, get vulnerabilities application function.php, HTTP 1.1 404 not found. So this is really what we're looking for here. Again, we talked about an application that's not working, that's talking to a web server, and it's looking for something that's listed under vulnerabilities/application function.php, and that's not on the server. So in our case, this is our problem here. Is there something wrong with the web server? I don't know. Is there something wrong with the client app? I don't know. Maybe they're on two different versions, but this is what's causing the problem. This is why that client app just stops working, or some function of the client app stops working. So we've now found what we were looking for. So now that we've found this packet, let's also mark it with a comment. I'm going to add the comment application function.php not found. And I'm going to go ahead and mark both of these packets. So I'm going to look at my packet details window here and zero in on this status code equals 404. I'm going to right click and go to apply as filter and selected. So you'll notice here that shows us a 404. To make this a more versatile filter, I want to remove the HTTP request, and instead of a response code equals 404, I'm going to add in a response code greater than 200. Since we know that 200 is HTTP okay, a lot of what comes after 200 are redirects and errors. So that really zoned in on our packet, and maybe we would use that if we were just looking for redirects or errors. Maybe that's the filter that we would use. But as you notice, it doesn't give us that full view of everything that was going on between the client and the server. So one last filter here that I will show you is to filter on only our comments. So let's say we were going to send this packet capture back to the apps team and we wanted our comments on there. We're going to take the start of our filter here and then add and frame.comment and hit enter. So now we get just our commented packets. And if we wanted to export those and send them to the apps team, we just go to File, Export Specified Packets, All Packets, Displayed, and then just give it a name. In this case, let's call it pcap for apps team. So now we just exported just those 4 packets, so the apps team can see exactly where the problem is. If you have any questions or comments about this video, please leave it in the comments section, and I'll do my best to answer. The next video will be something similar to this one, where we're really getting into the nuts and bolts of analyzing a pcap file. I hope you found this interesting, and I'll see you in the next video. Thanks.